This is 2.2 linear equations. So we're going to be using slope-intercept form, the y equals mx plus b. We will use standard form, which is ax plus by equals c. And then we'll be doing some horizontal, vertical, all sorts of graphing, just kind of reminding ourselves how all of that works. So let's start with slope-intercept form. Just a reminder that m, not the x, just the m, stands for slope. And the b is your y-intercept, so where your graph crosses the y-axis. So it's always a point, 0, and then whatever your b value is. So your x value is 0 and your y value is b. Okay, when you have things in standard form, we are going to locate the x and y intercepts by substituting in 0 for y to find the x-intercept and substitute 0 in for x to find the y-intercept. So let's start with number 1. First, we're going to identify what form it's in. Hopefully you can recognize that that's the slope-intercept, y equals mx plus b. So just kind of label this slope-intercept so that we know that it's that form. So that means we can identify that the slope is 2 and that the y-intercept is -3, which we're going to write as a point, 0, -3. Now you always want to graph the point first. So when you get to your graph, you're going to plot 0, 1, 2, 3, -3, and then we use our slope, and if it's not a fraction, then you're going to put it over 1, so we're going to go up 2 to the right 1, up 2 to the right 1. You can do that several times, and then use a straight edge to connect those dots. Okay, let's try number 2. Number 2 is also in slope-intercept form. Looks a little different because it doesn't have a plus b. If it doesn't have a plus b, that just tells us that our y-intercept is 0. So it would be the point 0, 0. Our slope is still this value before the x, so -4/3. Just like we did before, we are going to start by graphing the point, and then we go to our slope. Remember, the top number tells us to go up or down, the bottom number left or right. So we're going to go down 4, 1, 2, 3, 4, because it was negative, and then to the right 3, 1, 2, 3, because it's positive. Then we'll do that again, down, 1, 2, 3, 4, 1, 2, 3. Then we'll use our straight edge, line those up, and draw ourselves a line there. Okay, so now let's take a look at a little bit different kind of line. X equals 2. X equals 2 is not in slope-intercept form. It is a vertical line, okay, that goes through 2 on the x-axis. So you may have heard before the acronym HOI-VUX. I'll write that up here at the top. HOI-VUX. So the VUX part goes along with this, the vertical line, V-U-X. V standing for vertical. So when it's x equals, it's vertical, so x equals some number tells us that it's going to be vertical. And then the U stands for undefined, meaning that the slope is undefined. So when we go to graph it, we put on the x-axis our point at 2, and then we draw a vertical line using our straight edge going through 2. So all the x values are 2. Now, if you look at this next one, y equals -5, we use the acronym HOI. So we have y equaling a number, telling us that it is horizontal, and 0 is the slope. So it's a slope of 0. But we will go to the y-axis this time, go down to -5, and then we're going to draw a horizontal line using our straight edge. So that's horizontal and vertical. Next up we have standard form. Standard form is when x and y are on the same side, equaling a constant over there on the right side. So when we have it in standard form, we talked about earlier that we want to find our x and y intercepts. So since this is standard, we know that means we need to find an x-intercept and a y-intercept. Probably the easiest way to do that is to make yourself a little table. Okay, and to find an x-intercept, we have to put a 0 in for y. So in this equation, we're going to substitute 0 in for the y. So 2 times 0 would be 0. So this term completely goes away. All we have left is 6x equals 24. Divide by 6, we find out that x equals 4. So our x-intercept is 4, 0. We'll do the same thing for the y-intercept, except this time we're going to put a 0 in for x. So 6 times 0 is 0. That goes away. So all we have left is 2y equals 24. Divide both by 2, and we get 12. So our y-intercept is 0, 12. So when we go to graph it, we need to change our scale because 12 won't fit on here. So we'll need to count by 2's on our y-axis. 2, 4, 6, 8, 10, 12. So 0, 12 will go right there. You can count by 2's on your x-axis also, but you don't have to because we only have to get to 4. So I can count by 1's on my x-axis so I can get to 4. So I graph my y-intercept and my x-intercept, and then I connect them. Just like that. So on number 6, we have another one in standard form. Why don't you hit pause, try to find your x-intercepts and graph it, and then come back and check and see if you got it right. We have 5x minus 3y equals 15. You're going to need to find your x-intercept and your y-intercept. So we put a 0 in for y. That gives us 5x equals 15. Divide by 5. Our x-intercept would be 3, 0. Put a 0 in for x. Divide by negative 3. We get negative 5 there. So 0, negative 5. We're going to graph both of those. 5. 1, 2, 3, and then connect. So the first part of this lesson is all about identifying an equation from a linear equation, slope-intercept or standard or horizontal or vertical, and then being able to graph it. The last part has more to do with some word problems, putting together some information about linear equations. So let's take a look at these last couple. We want to find the slope that goes through the points 5, negative 2, and negative 6, 4. So that's one part. Then it says would, I think it's supposed to say this line, would line with this slope be parallel, perpendicular, or neither? Oh, I think it needs an A. Would a line with this slope be parallel, perpendicular, or neither? All right, well, we need to first start by finding the slope because that's what it asked us to do first, find the slope. So slope, you may recall, is y2 minus y1 over x2 minus x1. So we're going to do 4 plus 2 because it was a negative 2, so 4 minus negative 2 is 4 plus 2, and then negative 6 minus 5. So we have 6 over negative 11. So it says, would a line with this slope be parallel, perpendicular, or neither to this line? Well, in order to determine parallel, perpendicular, and neither, parallel lines have to have the same slope. So same slope exactly to be parallel. Perpendicular lines have to have slopes that are opposite. So one has to be positive, the other has to be negative, and they have to be reciprocals. So that means if one is A over B, then the other one is B over A to be perpendicular. And if it's neither one of those, if they aren't the same or they aren't opposite and reciprocal, then we would say neither. So now we need to identify the slope of the line that they gave us. The line they gave us, y equals negative 6x plus 11. Negative 6 is our slope. So if we compare negative 6 to negative 6 over 11, they obviously are not the same number. And they're also not opposite reciprocals because they're both negative and this doesn't even have an 11 in it at all. So these two lines are not parallel, they're not perpendicular, they are neither. So we found our slope and we identified parallel, perpendicular, or neither. All right, next up, we want to do the same thing. Determine whether the lines are parallel, perpendicular, or neither. So remember again, parallel, same slope. Perpendicular means that they're opposite and reciprocal, or neither. So we're going to have to find slope for L1 and slope for L2. So let's start with L1. Do our y minus y over x minus x. We find out that it has a slope of 3. Okay, and then L2, we're going to do the same thing. Y minus y over x minus x. And it also has a slope of 3. So, since both of these are the same, that means they are parallel. Scoot that up a little bit for you. Okay, so that's all there is to 2-2. Just identifying how to graph a line and then if lines are parallel, perpendicular, or neither.